In this next lesson called Using the Distance Formula to find the distance between 2 points on the coordinate plane, I have the example where we're given the points 2, 5 and negative 4, 3, and we're asked to determine the distance between them. So I'm going to plot the point at 2, 5 on my coordinate plane here and at negative 4, positive 3. Now I want you to notice that when I connect these 2 points, what they form is what's called an oblique line. An oblique line is one that is neither horizontal nor vertical. But if I were to draw a vertical line down from the highest point and a horizontal line over from the lowest point, what you notice I've formed is a right triangle. And I can see that in this right triangle, this vertical side of that triangle is 2 units long, and this horizontal side of that right triangle is 6 units long. I can see that just from merely counting the squares in my coordinate plane grid. Well, I know I may be getting a little bit ahead of myself, but one of the things that I know you've learned in the past in some previous math courses is that when you have a right triangle, and you want to determine the length of the hypotenuse, you can use something simple called the Pythagorean theorem. A squared plus b squared equals c squared, where c has to be the hypotenuse. So in our case here, we would take the legs, a and b, and they can be either one, 6 squared plus 2 squared, or 2 squared plus 6 squared. And they should equal the length of c, which would be our hypotenuse here. Well, if I continue on with my proper order of operations, 6 squared is 36, 2 squared is 4, and those added together must equal c squared. So c squared is equal to 40. And we know to undo squaring, we would need to square root 40. And so the distance between the points 2, 5 and negative 4, 3 must equal 40, or square root of 40, excuse me. Now, what I basically have here is an application of what's called the distance formula. This distance, this horizontal distance here, could be found by taking the difference between the x-coordinates. And this distance here, this vertical side, could be found by taking the difference between the y-coordinates. And according to the Pythagorean theorem, if I square those distances and add them together, I'll have the length of the hypotenuse, and to square root, and then to get the length of the I'll have the square of the length of the hypotenuse, and then to determine the length of the hypotenuse, I'll need to square root that. This is the distance formula. But if you just pause and graph the 2 points on the coordinate plane, I think it's easier to recognize that all that it involves is using the Pythagorean theorem.